voltage drop is a critical consideration in electrical systems, especially when dealing with higher voltages like 600 volts. It refers to the decrease in voltage that occurs along the length of a conductor due to the conductor's resistance. Excessive voltage drop can lead to several problems, including reduced equipment performance, overheating, and even equipment failure. To determine the appropriate conductor size and ensure safe and efficient operation, it's essential to calculate voltage drop accurately. While a specific online voltage drop calculator tailored exclusively for 600 volts applications under the Canadian Electrical Code (CEC) is not readily available, you can still leverage general-purpose voltage drop calculators and combine their results with the guidelines outlined in the CEC. Several online voltage drop calculators can be used effectively. Firstly, there is a voltage drop calculator available online. Secondly, another voltage drop calculator is available online. Thirdly, you can find another voltage drop calculator online. These calculators typically require you to input several parameters including the voltage of the circuit, which in this case would be 600 volts, the current flowing through the conductor, the wire gauge or conductor size, and the distance the conductor runs from the source to the load. Based on these inputs, the calculator determines the voltage drop, usually expressed as a percentage of the source voltage or as an absolute voltage value. While these calculators provide a calculated voltage drop, it's crucial to compare this value against the allowable voltage drop specified by the Canadian Electrical Code. The CEC sets limits on voltage drop to ensure proper equipment operation and safety. To find the allowable voltage drop limits according to the CEC, refer to Section 8 of the Canadian Electrical Code, Part 1. This section provides tables and guidelines outlining the maximum permissible voltage drop for various types of circuits. The CEC typically recommends limiting voltage drop to a maximum of 3% for branch circuits, which are the circuits that feed outlets and lighting, and 5% for feeders, which are the circuits that supply power to branch circuits or sub-panels. These limits are designed to ensure that equipment receives adequate voltage for proper operation and to prevent overheating of conductors. When using a general-purpose voltage drop calculator, first input the circuit parameters such as voltage, current, wire gauge, and distance. The calculator will provide a calculated voltage drop value. Next, consult Section 8 of the CEC to determine the maximum allowable voltage drop for the specific type of circuit you are analyzing. Compare the calculated voltage drop to the allowable voltage drop from the CEC. If the calculated voltage drop exceeds the allowable limit, you will need to increase the conductor size to reduce the resistance and consequently lower the voltage drop. Consider the following factors when calculating and addressing voltage drop. Firstly, conductor material. The type of conductor material, such as copper or aluminum, significantly affects the resistance and voltage drop. Copper has a lower resistance than aluminum, so it will result in less voltage drop for the same conductor size and current. Secondly, conductor temperature. The temperature of the conductor also affects its resistance. As the temperature increases, the resistance also increases, leading to higher voltage drop. The CEC provides temperature correction factors that should be applied when calculating voltage drop in high-temperature environments. Thirdly, circuit loading. The amount of current flowing through the conductor directly affects the voltage drop. Higher current results in higher voltage drop. Ensure that you accurately determine the maximum current that the circuit will carry under normal operating conditions. Fourthly, conductor installation method. The way the conductor is installed, such as in conduit, cable tray, or free air, affects its ability to dissipate heat. Conductors installed in enclosed spaces will have a higher temperature and therefore higher resistance and voltage drop compared to conductors installed in free air. The CEC provides ampacity correction factors based on installation methods. To effectively use voltage drop calculators and the CEC, follow these steps. Firstly, determine the circuit parameters. Identify the voltage, current, wire gauge, and distance for the circuit you are analyzing. Secondly, use a voltage drop calculator. Input the circuit parameters into a general-purpose voltage drop calculator to obtain a calculated voltage drop value. Thirdly, consult the CEC. Refer to Section 8 of the Canadian Electrical Code, Part 1, to determine the maximum allowable voltage drop for the specific type of circuit. Fourthly, compare and adjust. Compare the calculated voltage drop to the allowable voltage drop from the CEC. If the calculated voltage drop exceeds the allowable limit, increase the conductor size or reduce the circuit length to lower the voltage drop. Fifthly, consider dirting factors. Account for temperature correction factors, ampacity correction factors, and other dirting factors as specified by the CEC to ensure accurate voltage drop calculations. Sixthly, document your calculations. Keep a record of your voltage drop calculations, including the circuit parameters, calculated voltage drop, allowable voltage drop, and conductor size used. This documentation will be helpful for future reference and for demonstrating compliance with the CEC. While a dedicated 600 volts voltage drop calculator specifically tailored for the Canadian Electrical Code may not be available online, you can effectively use general-purpose calculators and combine their results with the guidelines outlined in Section 8 of the CEC. By accurately calculating voltage drop and comparing it to the allowable limits, you can ensure safe and efficient operation of electrical systems and equipment. Always consult the latest version of the Canadian Electrical Code and follow all applicable regulations and guidelines. Keep in mind that voltage drop calculations are essential for electrical safety and efficiency. Properly sized conductors and adherence to voltage drop limits help prevent equipment malfunctions, overheating, and potential fire hazards. It is always best to consult with a qualified electrician or electrical engineer for complex installations or if you have any doubts about your calculations. Remember to consider all relevant factors such as conductor material, temperature, circuit loading, and installation methods when performing voltage drop calculations. Accurate calculations and careful attention to detail are crucial for ensuring the reliable and safe operation of electrical systems. By utilizing the available online calculators and referencing the Canadian Electrical Code, you can effectively manage voltage drop in 600-volt applications and ensure compliance with electrical safety standards. Furthermore, consider that certain types of equipment are particularly sensitive to voltage variations. Electronic devices, such as computers and programmable logic controllers, require stable voltage levels to function correctly. If the voltage drops below a certain threshold, these devices may malfunction or shut down completely. Similarly, motors can experience reduced torque and increased heating if the voltage is too low. This can lead to premature motor failure and reduced efficiency. Therefore, it's essential to ensure that all equipment receives an adequate voltage supply within the manufacturer's specified range. If you are dealing with sensitive equipment, it may be necessary to use voltage regulation devices such as constant voltage transformers or automatic voltage regulators to maintain a stable voltage supply. Additionally, consider the impact of future load growth on voltage drop. As you add more equipment to a circuit, the current will increase, leading to higher voltage drop. It's a good practice to design electrical systems with some spare capacity to accommodate future load growth without exceeding the allowable voltage drop limits. You can achieve this by oversizing conductors or using voltage boosting devices. Also, remember that voltage drop is not the only factor to consider when selecting conductor sizes. You must also ensure that the conductors have sufficient ampacity, which is the current carrying capacity of the conductor, to handle the maximum current that the circuit will carry. The CEC provides tables that list the ampacity of different conductor sizes based on their insulation type and installation method. Always select conductors that have an ampacity greater than or equal to the maximum current that the circuit will carry. In addition to ampacity and voltage drop, you should also consider the mechanical strength and durability of the conductors. Conductors must be able to withstand the physical stresses and environmental conditions to which they will be exposed. For example, conductors installed in harsh environments, such as those with high levels of moisture or corrosive chemicals, should be made of corrosion-resistant materials. Conductors used in overhead power lines must be strong enough to withstand wind and ice loads. Ultimately, The selection of conductor sizes and types should be based on a comprehensive assessment of all relevant factors, including voltage drop, ampacity, mechanical strength, environmental conditions, and applicable codes and standards. It is always best to consult with a qualified electrician or electrical engineer to ensure that the electrical system is designed and installed safely and in accordance with all applicable regulations. Lastly, regular maintenance and inspection of electrical systems can help to identify and address potential voltage drop issues before they become serious problems. Check for loose connections, corroded conductors, and damaged insulation. Repair or replace any damaged components promptly. Periodic voltage measurements can also help to identify circuits with excessive voltage drop. If you notice any signs of voltage drop problems, consult with a qualified electrician to investigate and correct the issue. By following these guidelines and recommendations, you can effectively manage voltage drop in 600 volts applications and ensure the safe, reliable, and efficient operation of electrical systems and equipment.